How does stoichiometry work in chemical reactions? Have you ever wondered how scientists predict the amounts of substances involved in chemical reactions? The answer lies in a fascinating area of chemistry called stoichiometry. This branch focuses on measuring and calculating the quantities of reactants and products in a chemical reaction. At the heart of stoichiometry is a fundamental principle: matter is conserved. This means that the total mass of substances before a reaction equals the total mass after the reaction. This principle is known as the law of conservation of mass. To understand stoichiometry better, we need to look at balanced chemical equations. These equations show the exact proportions in which elements and compounds react and from products. Each equation includes coefficients, which are numbers placed before chemical formulas. These coefficients indicate the relative amounts of each substance involved, usually measured in moles. For example, consider the reaction of methane burning in oxygen. The balanced equation is 1 molecule of methane plus 2 molecules of oxygen produces 1 molecule of carbon dioxide and 2 molecules of water. The coefficients tell us the ratio in which these molecules react and are produced. Using these ratios, stoichiometry allows us to calculate how much of one substance is needed or produced when given the amount of another. The process typically involves 3 steps. First, you convert the known amount of a substance, usually measured in mass, into moles. This conversion helps count particles in chemistry. Next, you use the mole ratio from the balanced equation to find the moles of the desired substance. Finally, you convert the moles back into mass or volume, depending on what is needed for your calculations. This method is incredibly useful in various fields, including chemical manufacturing, environmental science, and biology. It helps answer practical questions, such as how much fuel is needed to burn completely or how much product will form from given reactants. In essence, stoichiometry acts as a map of proportional relationships between substances, allowing for precise calculations of amounts involved in chemical reactions. This process connects the microscopic world of atoms and molecules to measurable quantities in our everyday lives, satisfying our curiosity about how substances interact and transform.